Okay, hi. In this video, I'm going to describe about CRISP DM. And here we have a case study. I found this website and actually it has very interesting case study to look at. In addition, we're gonna see that they already prepared some dashboard showing how the system was deployed for building a dashboard, and also was built to provide insight on the factors that contribute to each cluster. So also they applied clustering. So we're going to see that after I explain about CRISP throughout this project. So as you're already aware, CRISP meant to be used for a full cycle when you work on data mining case. And by the way, machine learning is part of data mining. So the first step in data mining, you need to go into looking into business understanding, then you move forward to data understanding, then data preparation, modeling, evaluation, and deployment. And of course, as you see that there is always an arrow to take you back to any stage. So that means you, at any time you found there's a need to step back, then by all means you can do so. So for example, while you are in data understanding, you wanted to get back and have more insight about the business understanding, then you can do it. Same, for example, in modeling, you can go back to data preparation and so on. So let's look first into the problem. Let's say you are working in a company, okay, automotive company, and the company has decided to employ data mining. So they gathered the technical team, let's say the IT team, and they sit down to explain about the problem from business perspective. So according to the business perspective, for business understanding, that the company is facing stagnant profits. So for the last 5 years, the monthly average profit has been constant and there is no significant growth. And the condition, they anticipate the condition is going to be same in the future if they don't do something. And in order to do something, they have two options. The first one is to locate more members into the sales team to approach potential customers, because they believe they already have potential buyers, customers. But the problem is they don't have enough sales team. Okay, so this is the first option, and it would be very inefficient and wasting a lot of resources to target all the leads. Okay, so they have a list of customers, but targeting all of them is going to be require a lot of resources. And instead, what they're looking for, instead of expanding actually the team, so what they're looking for, they look to employ data mining. So they need, based on the data that they already have, so they need to be able to quickly inspect and prioritize which customer is a potential buyer. Okay, so keep this in mind. This is the first thing. In addition, they would like to know what drive customers to purchase their product. So in other words, we're looking into the contributing factors. What are the contributing factors that drive the customer to purchase products? And in addition, they're looking to prioritize. So this we already mentioned, but the point is they're not just only looking whether the customer is potential or not, but they need some indicator to say how potential the customer is. Okay, here is the average profit for this company. Keep this in mind because we're gonna get back into this. So in short, the summary, they have stagnant profit because the number of sales is constant. The number of sales team is constant, and again, they're not looking to expand their team. There are a lot of customers leads, but they cannot reach all of them. Third, we need to know which customer leads that should be prioritized, and we need lead scoring so that we can be efficient on targeting potential buyer. This is just what I mentioned. So not only they need from the system to tell them whether the customer is potential or not, but how potential the customer is, okay, by a leading score. So what are the business objectives? So here is the problem. Then we need to go into business goals or business objectives. So the business objectives are first to gain insight on what drives people to buy our products. Again, what are the contributing factors toward driving the customer to purchase products. Second, they need to increase profit by 10% year over year. This is business objective from business point of view. Third, they need to reduce annual marketing cost by 10%. Okay, so again, those are business objective. Now, once you have the business objective, you need to translate them into data mining goals. Right? When you talk about data mining goals, so probably you are looking for accuracy, recall, precision. Okay, so these are important to set after having your business goals, because these are gonna be an indicator whether the model you are building has achieved its fulfillment, at least from the perspective of data mining goals. Once it has fulfilled these conditions, then only then we can look into the business goals, whether the project has achieved the business goals or not. Okay, so this is under business understanding. You finish with data mining goals, then you move on into data understanding, as this example shows us. So in data understanding is where you try to describe and explore the data. Okay, so what you can do is looking into data description, apply some early data exploration, and check on data quality, prepare data quality report. Okay, you don't need to do any fixing for the quality or enhancing quality, in other words, but only you need to report about them. So we start with gathering and describing data. So here they have collected, or they already actually obtained the data from sales department. Here is the data, and they're going to describe it. So they can look what kind of data they have, how many entries they got, okay, how many factors or how many columns, and so on. Then what are these columns contains? So here we can take a glimpse. For example, you can apply to check the first 5 or 10 rows from the data set to see what type of data you have, how does it look like, and so on. So they have 40,000 customer, distinct customer. That means for each row inside the data set is referring to a single customer. And here the description about the data set. So we need to know what these factors are. And then here in this example, they're showing you they have done some early data exploration. So inspecting the data, looking around what it is, and then reporting about it. So for example, here they're looking about all the categorical variables they have. Okay, so for example, flag, this to indicate whether the customer has made purchase or not, yes and no. So actually we have a balanced data set in terms of flag according to the flag attribute. So we have 20,000 customer who eventually haven't purchased the product versus 20,000 customer who actually have purchased the product, and so on and so forth. Then they have determined that they need to do some data cleansing. They need to make sure the data format looks nice. So for example, instead of having U indicating that these are unknown or missing values, so they need to replace with the word unknown. For example, they need to take these prefixes and just keep, for example, this as unknown and etc. So anyway, it's just about data format, how the data should look like, just make it consistent and so on. Okay, so again, these just under data understanding. You don't take any action at this moment. Of course, you can report about any data quality issue, as we mentioned, missing values. Maybe you can inspect if you find outliers and etc. Then we move into data preparation. So under data preparation, we have data cleansing. So after they've done data cleansing, the data set has ended up looking like this. So you can compare between them. So as said, for example, instead of having N and yes or no and Y, then they make it clear no and yes. Unknown used to be U, now it's written. They took those leading numbers because the data was used by sales department, so they wanted to make sure that it looks neat, okay, for further analysis. Then of course at this moment also you can do any, you have missing values, you may also take initiative. You can take the step what is required to fix your data. Of course this is here, not all steps are mentioned. For example, maybe you need to apply data mapping where you need to do converting categorical to, or map it to discrete values. You may need to apply data standardization, feature scaling, and etc. So all of these under data preparation. Again, this is just to give you a glimpse, an idea how it works, but the important part we're gonna see is how to link all of this back to the idea of business, how the business should benefit from having data mining in place. Okay, so this is here the final data that they got. The final data, here are the columns. And then they move again to data understanding. So here, after the data is clean, they, in this case, they again look into exploratory data analysis. Okay, so for example, they got some visualization element looking for house valuation distribution for those customers in light with whether the customer has made purchase or not. So we see actually the figure shows mixed results, mixed flags for based on the house valuation, and then also decided to trim those houses. We have few houses that exceed the value of 2,000 or 2,500,000 and keep it just up to, I think, somewhere 200,000. Sorry, 2 million. Inspecting education, just to take a look whether education has any potential factors. So again, it's about exploration. You're exploring your data. For example, here they've done they got heat map. So heat map is going to show based on the flag, education versus flag, and it's going to show the frequency. And the heat map, as you see, it's colorful, so indicating, for example, the lower frequency you have for such category is going to be with lower or with darker number, and those that with lighter, that indicating that the frequency is high. Or you can actually also use box plot. For example, you can see whether there's also potential factors, whether, for example, education is good or not, and etc. So here we can see that those indicating the high frequency for bachelor and grade, indicating that there might be some pattern, and might be this education can actually make it clear, or actually can be a potential factor to assist to find out whether the customer is going to be potential or not. And same for occupation. Okay, so after you're done with exploration, okay, also you can do maybe some statistics. So you can look also for describing your categorical variables, looking into them. You can also look into summary of statistics for numeric variables. For categorical, you can do looking into how many categories you have, and etc. The distribution for those categorical values inside or across your target variable, and etc. Then we move on into modeling. So here in this example, they're going to use view modeling. Let's see what they have decided to apply. So here they're giving you some idea what is supervised, unsupervised, reinforcement, and etc. So you may look into them if you are interested. And then showing you the machine learning workflow. Okay, workflow. Though I'm not sure why cross-validation is here at this stage. I'm not sure at this stage why cross-validation is right after data cleaning. Okay. Anyway, so you start with importing data, data cleansing, and etc. So this is about machine learning model. But again, cross-validation, I believe, should be after you fit your model. Then you need to evaluate your model. So let's see why they have done at this stage. Okay, so splitting the data set. Actually, you can follow different time of splitting. So instead of doing splitting at this time, actually even before doing data preparation, or even looking into data understanding and do some early exploration, you can split up your data set into training and testing and leave the test set away. Why is that? Because we need to ensure that later when it comes to the time where we conduct testing for the finalized model or models, that we need a data set that assemble the reality. Because when you deploy your model, you are going to get data similar to this one. So we should be ready. We need to evaluate our model to real case scenario. And the best way is to use the data set. So the test set. So the test set is going to be just split it up at early stage and kept away all the time. So it shouldn't be involved in any part, in any process during training or even during internal evaluation, or maybe hyperparameter tuning or whatever. So all these steps that related to finalize your model, test set should be away from it. That means the model should have no idea about the test data. In other words, when we come to the final evaluation before model deployment, then we can have authentic, okay, or reliable test to see how the model gonna perform when the model is actually deployed. Okay, so in this example, they're going to split the data set 80 for training and 20 for testing. So in this example, they're going to use decision tree, random forest, and then to model evaluation. But of course, you may inspect many more, not just only decision tree and random forest. So you can go for more, and then maybe the shortlisted, let's say, algorithms or models can further been taken to do hyperparameter tuning, maybe apply ensemble learning, and then you come up with your final model. Okay, so not only up to 2, but you can actually have initial testing on all, and then you may pick those that show potential, and then you carry on building and finalizing those models. Okay, so they're explaining about decision tree, random forest. The good thing about random forest, it has the ability to pinpoint those important factors. So actually you can check the importance or the important factors using random forest. Okay, so now here it shows that house valuation, the family income, customer psychology, age, and etc. And this is the most important one, going to other factors. Then we come to model evaluation. Since we're talking about classification, so confusion matrix is good, right? So we are aware of it. It's, since here we have binary classification, so we have 2 by 2. So here we have the true, actually positive, actually negative. We have predicted positive, predictive negative, and so on. Now you may actually swap between these two. Sometimes they would put the predicted at the top, the actual on the left, but anyway, the point is, you know which one is true positive, which one is false positive, and so on and so forth. So here they already provided description about each. Okay, so here for each one, how many, the frequency, how many we have. And now it comes to other evaluation. They're going to use accuracy. Remember, according to the data mining goals, they're going to use 3 metrics. We have accuracy, recall, and precision. Okay, so here the accuracy. So since we have the frequency for the distribution for each of these values, we already obtained them, then just it's straightforward equation where you substitute and finally you get each or the result. So here we got accuracy 65%, 67%. Okay, for recall they got 84%, precision they got, for precision, 67%. Okay, So here are the values for decision tree and random for each of these values. Then you may check whether those fulfill your data mining goals or not. In case they do not fulfill, then you may step back, go check, or maybe do further data preparation if you need to apply data standardization and etc. So you may look into your data again, maybe applying other algorithms. If you feel that these algorithms do not show enough potential, maybe you pick other algorithms, okay, and so on until you are satisfied. Then you move further. Okay, now the interesting part here is how they link, how they show that the model actually is doing in terms of business perspective. So we already know about data mining goals. If you study any data mining goals or machine learning, most likely, definitely you will come into understanding all these metrics: accuracy, recall, precision if we are talking about classification, mean square error, and others if we talk about regression. But the link between the technical stuff and linking it back to the business perspective, it might be not enough clear. And here actually it's interesting, they already pinpointing how to check whether these can actually fulfill the business objective or not somehow. Okay, so one way is to check on cost and benefit analysis. So the cost and benefit analysis is where we try to convert machine learning performance into business context, right? And this is the important part. After all, whatever the company is employing, it's employing, or it is employing it because it needs to gain benefit after all. And all these objective, whatever technical stuff have been done, they should be linked back into the business context. Okay, so let's see about cost and benefit analysis. So first we need to do is to define the cost and benefit of each decision. Okay, so we will define it similar with the previous confusion matrix. The main cost is the cost approaching customer. And in here we defined as 600. That means the company has to spend 600, okay, in order to approach the customer, regardless whether the customer will buy a product after all or not. They have to spend this amount. The revenue generated in case they successfully or succeeded where the customer has actually ended up purchasing the product is 1000. In this case, the profit is 1000 minus 600 is going to be 400 after we cut the revenue with the cost. So what does that mean? So when it comes to the true positive, that means the company is going to get the profit in 400, right? Because the customer, after all, is going to purchase and we have approached the correct potential customer. So the company is going to make a profit 400. What does it mean false positive? That means the company has approached a customer where the system has pinpointed as potential, but actually it was false. That means the company is going to spend 600 and this 600 won't yield any revenue, just gone. So the company, in other words, will lose 600. True negative, that means nothing gonna happen. The model has anticipated that the customer is not potential and actually he or she is. While false negative, the model predict the customer, let's say, is not potential, okay, but the prediction was incorrect. And here they anticipated nothing gonna happen because the company, after all, won't actually spend any money to approach this customer. Okay, so nothing happened. Okay, so in terms of that, then let's continue and see. Now it comes to, we will prioritize the customer that has the highest probability to buy a product. That means we're going to generate the probability, not only whether indication that the user is going to purchase or not, but how much efficient or how much confident in that decision. Okay, so for example, here for customer ID 381, the system predicted or gave probability that he is 100% potential customer, and the truth is yes, and actually it is. So this is under true positive, and same for second case. Okay, while the third case, the model has predicted that for this customer is potential, but actually yielded no, right? So here there is false positive, and so on and so forth. Then we calculate how many profit we will get if we target and approach only some percent of the total customer. Okay, in other words, we need to see how much profit we're gonna make if we approach, for example, 10% of these based on the list, based on the probability. Okay, so if we pick the top 10% customers, then how much profit we're gonna make in light with what we have defined for true positive, true negative, and so on. So for example, if we target the top 10, so here the top 10 customers, for example, and ignore the rest, just looking how much profit we're gonna make. So here it is just an example. So in this case, if you count, those are potential, right? Because we have picked the top 10, that means we're gonna spend the 600 to approach all these customers. Now the profit or the revenue is going to be generated only out from 10 out of 10, only 8, because we got 8 of them yes, while no actually were under false positive. So in this case, we're gonna make profit 400 from 8 customer only. And then for the other two, we're gonna actually lose the 600 that the company is going to put to approach these customers. Then those will yield negative loss, and finally the profit is going to be 2000 if we approach the top 10. Okay, so the final profit is 2000. Now we increase the number of people that will approach by using the top 20 leads based on their score. So already the values all here, and then you calculate. So now the profit has become 6000, right? Actually it's more than double what we would get, triple, 3 times more what we get if we approach just double, 20. Here was 10, here 20. Okay, because those we have 18 correct, 2 incorrect. Okay, so now that's how we will calculate the profit. We will do the same thing, but calculate some level of percentage or percent of people that will be targeted. The final result is the following profit curve, which shows the total profit that can be generated by targeting the top percent of the customer. And this figure actually showing the highest profit you're gonna make by targeting top 10%. That means you're going to target 332 individuals or customers. Okay, so here is the average profit. Remember the average profit we've seen at the beginning, where the company is making. So it was about 100,000. Okay, so it's about 100,000. This is the average profit. Let's see how much the company is gonna make. Now, if the company consider 64% of those individuals, so the company will make 262,000. Okay, which is way more than the 100,000 the company already do. And that means actually it has an increase by 186 from the current average profit, right? Actually it's quite easy to calculate. Just here you take 262,400 minus the average profit, and then see the percentage, that how much percentage the profit has grown. Okay, so that's quite good, right? 182. And remember, they were looking for profit increase 10%. So now you can check whether you are fulfilling at least the business objective or not. We also show you how many profit generated by random classifier, which is just simple random guessing. Okay, so in addition also they look if you have just a classifier just random guessing, 50% probability, just to consider a customer as potential or not. Okay, so the random is here, pinpoint by this gray line. We can also add some scenario, for example. So now we may check back based on the business understanding. So the sales has only monthly budget, this amount. Based on this, then we can decide how much percentage we need to approach, right? Because again, we're not going to approach all the customers, of course not. And then maybe in light with the budget the company has, then we may decide how many individuals we need to approach. Since the cost of approaching each customer is 600, so just we divide, and then that means we can approach per month 800 individual, and that means top 24% only. So in this scenario, anyway, the company is still gonna make significant or big improvement, 177, while now again it just make about 97 to 100,000, okay, which is still a big improvement, and of course is actually more than 10%, more than 10%. Okay, so the overall process that they have done, so they're looking into improper input data, underperforming model, data gathering is not done in real time yet. So they're looking about the overall process is quite smooth with some flaws. So what are these flaws? They mention some, and the final decision, let's say to do improvement and etc, etc. And now let's say that they all satisfied about everything, and now it's the time to come to the deployment. So you need to have a deployment plan. Okay, so deployment plan is how the system is going to work. Maybe you can talk about the environment, any prerequisite software required, or any specific hardware, and etc. So all it's about deployment. But also the interesting thing, okay, is to mention how the system is going to be utilized. So far we just built a model. Of course, in reality, you cannot just have model on hand or in hand and then do what? So we need to deploy, we need to integrate probably this model into somewhere, okay, like we are doing post-processing. We need to integrate the system into somewhere, probably by building dashboard or building API. So that means the API is going to be like the interface that other systems or the company system are going to interact through. So the system will be deployed, the model, and then some APIs are going to be provided. It's just like an interface to deal with the model. So other systems will, if they need any information or prediction or whatever, then they can interact with the model. Of course, not directly, only through the API. Through the API. You can think of them as just like HTTP URLs. You can add, delete, whatever, I mean, based on what API you have provided. Okay, so you need also to have deployment plan, of course, and then monitoring and maintenance. So you need also to keep monitoring the performance of the model ongoing while it's in real time. If there is shortages going on, then you need to inspect, right? For example, you need to monitor how the performance, the accuracy and recall and etc. You need to keep an eye on them, not just only during building, but even after launching or deploying your model. And even you may decide what plan you need to do in that cases. Let's say if the threshold of accuracy has dropped down, so then what you need to do. For example, if you are using online learning algorithm, then probably because the data has become noisy, something happened, so now the performance of the model has started to degrade. So probably you need to stop the learning process, just what the model has learned, or maybe go back to another build, okay, early model build. So you need to decide about this stuff. Now, what else they have provided here? So finally, the conclusion is, since we talk about deployment, so there is a dashboard already provided just to show you an example about the case. Okay, and also they provided you some information. You can go how to deploy your machine learning in production. Okay, so be an application. Is it your model is going to be an application standalone by itself or part of another application? Is it going to be called through API or web services? Okay, if web services, then you need to have a proper protocol available for web services. API, you need to have RESTful. Okay, methods to build web services, and etc. So examples of how to deploy in production. Okay, it says in the next session, then I'm not sure if they have provided enough link about the platform, right? As I said, maybe if you have prerequisite, but here even actually they're not talking about that, but they're talking even where this system is going to be deployed. Are you going to use Google, Microsoft Azure, Amazon, Oracle, and so on and so forth? Python packages required, right? And etc. So it's quite nice. Let's go to the dashboard and see how interesting. So here you can check predicting whether a potential customer will buy or our product is critical for sales team. Targeting the right customer with high precision can save cost of targeting the mistargeting while also increase the sales. Seems like the process. Okay. So let's just give it a few seconds. I think should be fine. Okay, here is an overview of number of people who bought our product. We can break down the number of people who bought the product based on category. For example, you look into gender. Then for those under category no, how many of those the male versus female, and etc. So actually it's nice. And even this actually can give you an idea, since it's real time, is going to be later on. That means the data is going to change, right? You're going to get new data and etc. So actually those can keep updating. It's not just something static. And then what else they got here? They also has provided clustering. Okay, so this can help you to get or to find the unique characteristic for each cluster. So you need to select the number of cluster. Let's do start clustering. So we're looking for 4 clusters. Now the biggest cluster among these, that means here we got the highest number of customer, is cluster 4. Okay, the percentage, this one is 54%, where we got over 5,000 customers. Then we check into the tree map. Let's say inspecting flag. This is the cluster 4. So here we have, based on flag, in this cluster we have a lot of customers who actually yielded or at the end eventually have purchased product. You can look into gender, again cluster, so you can understand about your cluster. This is the biggest cluster. Then you may maybe drive marketing plan to approach males, maybe because the probability is higher, right, to have versus female. Okay, maybe on the level of education for cluster 4, then what we got? Some college and bachelor, then graduate, and so on. So this is about clustering. Clustering because actually try to group all the customers, okay, into different clusters. And then we can inspect what unique factors we have in here. Okay, so for example, now the age, let's check on the age. Okay, so 50, so the majority you can see into cluster 4, it's for customers whose age between 36 up to 55. So probably you target those more than, for example, taking people whose age is less than or equal 25. Okay, so table shows the most common characteristics. So this is for each cluster. So the most common characteristics. So for cluster 4, We have the size, how many customers? 6,000. The flag is yes, right? The majority, the gender is male, as just now what we actually inspected earlier. The unique one, or the highest one, is bachelor, right? Just now I believe what we've seen when we went to education, it was bachelor. So actually it's very interesting, right? The age is this one. Online, that means whether the customer has an experience of purchasing online, customer psychology, marriage, and etc. And of course you can play around the increase and etc. You can also, they already provided prediction. So if you got a new case, then you can predict whether the customer will be has potential or not. So let's try, just pick anything. And here they have provided 3 machine learning models: naive Bayes, decision tree, random forest. Okay, so the prediction based on naive Bayes, this customer has high actually is predicted to be a potential customer, but the probability is 70%. How about decision tree? Decision tree also predicted that this is potential customer, but the probability is less, 60%. How about random forest? Also random forest says this is a potential customer and the probability is 58%. And for each one you got the precision and etc. So actually it's very interesting. It's very interesting. So it shows you how the system has been deployed, how it's utilized. Here, if you like to check on the data, you got, okay. So I hope this actually shows you a very interesting case, how CRISP DM is applied throughout this. So again, this is not finalized. This is just to give you a case study. As I said, always you can refer back, come forth, go forth and come back, okay, while checking each and every stage. Okay, thank you, have a good day.